Viewers, good morning. This is Ravi Kumar. Now I am going to deal thermodynamics. So thermodynamics is a branch of physical chemistry which deals with thermo contains two terms, that is thermo and dynamics. Dynamic is work, thermo means heat or energy. Thermodynamic gives a relationship between heat and work. So thermodynamic gives us whether the reaction is feasible or not. Okay, so whether the given reaction is spontaneous or not. So this is very important. Thermodynamics topic is very important. Based on these conditions, we can say, okay, what type of conditions, what type of whether it is spontaneous or non-spontaneous, it can be easily explained with the help of thermodynamic principles. So let us see what are the basic terminology in thermodynamics. First of all, introduction of thermodynamics. Introduction. This is a branch of physical chemistry which deals with heat and work. Okay, whether the process is feasible or not, based on thermodynamic properties or thermodynamic conditions. Now, the three empirical laws. The thermodynamic science is an exact science because the generalizations the generalizations of thermodynamic principles are obtained from the experimental results. So that's why each year the three empirical laws, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. These three laws are expressed in the form of mathematical equations. That's why thermodynamic science is an exact science. And coming to the limitation of thermodynamics, here the thermodynamic properties TD is applicable to thermodynamics applicable to only macroscopic systems, that is bulk system, bulk of the matter, not for the microscopic or individual atoms. So next condition is whether this is there is no time factor, there is no time limitation in thermodynamics. The based only whether the system is obtained equilibrium. So these are the limitations of thermodynamics. Types of thermodynamic systems. Generally, systems are two types. That is homogeneous system and heterogeneous system. Homogeneous system is uniform throughout, it is called homogeneous system. Heterogeneous system is one which consists number of phases, that is called heterogeneous system. So this is general homogeneous and heterogeneous systems. But coming to the thermodynamics, types of thermodynamics, here there are three types based on nature of boundary. The thermodynamic systems can be classified into three types. First one is open system. A open system is one which can transfer matter as well as energy to the surroundings. That is called open system. So for example, when we keep hot water on the table, you will observe after some time we can find matter, that is water, as well as energy can transfer to the surroundings. That is called open system. So for example, this is hot water with beaker, we keep on table. So the energy and matter can transfer with the surroundings. That is called open system. And next, closed system. A closed system is one which can transfer only heat to the surroundings, not the matter. So, for example, when we cover this beaker with seal, only the water vapors returns to its original state. The energy can be transferred to the surroundings, that is called closed system. A closed system which can transfer heat or energy to the surroundings, not the matter, that is also called closed system. And coming to the third one, that is isolated system. Here, an isolated system which can transfer neither energy nor matter to the surroundings. That is called isolated system. The best example for isolated system is a tea in a thermoplastic. So, when generally we use thermoplastic, but here there is no change in the value, there is no change in the heat. That is called isolated system. Macroscopic properties or bulk properties of a system can be divided into two classes. The first one is intensive property and second one is extensive property. Let us see intensive property. A property which does not depend on the quantity of matter in the given sample is known as intensive property. The examples for intensive properties, that is temperature, pressure, boiling point and viscosity and surface tension, concentration. These are the best examples for intensive properties. And for example, 100 ml of water has boiling point is 100 degrees Celsius. 1 drop of water has 100 degrees Celsius temperature. So that does not depend on the matter of the sample. Second bulk property of the system is extensive property. A property which thus depends on the quantity of matter in the given sample is known as extensive property. Okay, let us see the examples. For example, value is one of the extensive property. This extensive property, for example, 1 ml of water and 10 ml of water and 100 ml of water, these are the depends on the water quantity, that is nothing but matter. So value. Or next example is enthalpy, the entropy and Gibbs free energy delta G. These are the best examples for extensive properties.